In this video, I'm going to continue the topic of the four-layer internet model, and I'm going to tell you about the icmp service model. icmp is the Internet Control Message Protocol, and it's used to report errors and diagnose problems with the network layer. You'll recall that IP doesn't provide any guarantees about delivery, but it does help, and it'll prove to be a very valuable tool to get some hints and some information back from the network layer to tell us about when things are going wrong. There are three mechanisms that we use to make the network layer work in the internet. The first we've already seen is the Internet Protocol, or IP. This creates IP datagrams and then delivers them hop by hop from end to end. The second are the routing tables sitting inside the routers. There are algorithms that run to populate these router forwarding tables so that the routers know how to deliver them hop by hop to the other end. The third mechanism, which is the purpose of this video, is icmp, or the Internet Control Message Protocol. icmp helps communicate information about the network layer between the end hosts and the routers. And I'm going to show you a couple of examples of those in a minute. It's typically used to report error conditions and helps us diagnose problems, figure out the path taken by packets, and so on. Okay, icmp runs above the network layer, and so strictly speaking, it's a transport layer protocol. When an end host or router wants to report an error using icmp, it puts the information that it wants to send back to the source into an icmp payload and hands it to IP to be sent as a datagram. Let's look at an example. As I said, icmp typically gets used as a method for error reporting. And in fact, you've seen it if you've ever seen the message destination network unreachable. So let's look at an example. Imagine that I have a web client running as the application here. So I've got an HTTP or web client here that's going to be accessing an HTTP server over here at B. So as we've seen before, the application bytes that for HTTP get put into the transport layer as usual, into TCP, comes down to the network layer, goes out along the link, comes up to the router along here. Imagine that the address that is put in here is actually to a network that this router has no information about in its forwarding table. Now this would be a pretty bad situation because that router doesn't know how to forward the packet to B. But if that happens, then the router will send back a message, and so this will come back down through the network to A, and it will say in it, destination network unreachable. And that's simply saying that it has no means to deliver that packet to B, so it's alerting A by sending that back. And we'll see the format that it uses in a moment. So basically the icmp service model is very, very simple. It allows it to send a reporting message, a self-contained message reporting the error. It's unreliable in the sense that it sends a simple datagram. It doesn't attempt to resend it. It doesn't maintain any state of the messages that it sent. It simply sends back a digest, giving an indication of what the problem was. And in fact, how it actually works is when a message comes in, so for example, an IP datagram. So here is my IP datagram. Here is the header. Here is the payload or the data portion of my IP datagram. So this is my IP datagram. Let's say that this has just arrived, and in my previous example, this has arrived from A to the first router. If the first router wants to send back an icmp message, what it does is it takes the header. Now this header here has source address A and destination address B. And it will populate this it'll place this into an icmp message. So it will take this header and put it into the icmp message. So this is my icmp message. And it will also take the first 8 bytes of the IP payload, and it'll put this into the icmp message. And then it marks it with a type and a code, and we'll see some examples of these types and codes in a moment. And then the whole lot gets placed into a new IP datagram. So this is the data of the new IP datagram, and this is going to be sent back. So this is the header, and so the IP source will be the router. So I'll just R for router, and the IP destination in my example will be A. It's going to send it back to A to tell it that this was the error, this was the type of error, this is how it figures out what type of error it was, this was the data associated with that error, it's the IP datagram that was originally causing the problem. That's all placed into the data of the IP datagram that goes back again to A. There's a good example of some particular ICMP message types. There are a lot of message types. This is just a sampling of them. These are the 6 most important that we see, and you don't need to remember the types or the codes. You'll find those in the Internet RFC 792, and you can just look that up online if you want. These are the ones that are most commonly used, and I'll just go through examples. We've already seen the network unreachable. This was type 3, code 0. And there are 2 other destination unreachable ones. Host unreachable, that's if a IP datagram gets to the last router, but then the last router doesn't know where the host is. Port unreachable means that the port that's contained inside, or the protocol ID that's inside the IP datagram, it doesn't know what to do with it. It doesn't recognize it at the other end. We'll see how echo reply, echo request, and TTL expired are used in a moment. Okay, you've probably used the ping command before, and ping is used just to test the liveness of another host, and it also checks that we've got connectivity to that host. So imagine that we're sending a ping message from A to B. So we're sitting at A, and we run the command ping B. Right? And you've probably done this. If you haven't, just try this on your computer. Pick the name of a computer, like www.stanford.edu, and just type ping www.stanford.edu. The ping application calls ICMP directly. It sends a ICMP echo request, and so that will be a message that goes into the network. So this is an ICMP. So this is ICMP. And it's happens to be a message of type 8, code 0. And if you look on the table before, that's actually a echo request. And then that gets encapsulated at A into an IP datagram. So this is my IP datagram, and it's going to go off to B. As this goes through the network, it's going to go across to B, we hope. Eventually it'll reach B. And then B is going to see this, and what B is required to do is to send an echo reply. So it will send back towards A, it will send the ICMP, and the ICMP will be I think it was type 0, code 0, which is the echo reply. This gets placed into an IP datagram. So this will all be placed into the IP datagram, and it'll be sent back to A. Nice and simple. So that's how ping works. Now let's have a look at how traceroute works. Traceroute is an application that tells us the path that packets take through the network and the routers that it visits along the way. You can try this by simply typing traceroute and then the name of a web server or some other server on the network into your computer, as I'm showing here. Traceroute is going to tell us not only the path taken by packets, but the round trip delay to each of the routers along the path. So traceroute uses ICMP in quite a clever way. So the goal here of traceroute is to find the routers on the path from A to B. So it's trying to identify the 2 routers along the path and measure the round trip time of packets from A to each of those routers. So traceroute does this by sending UDP messages, and I'm first going to describe what it does, and then we'll see why it is that that works. So A is going to send a UDP message. So it's going to send a UDP message, and that UDP message is going to be sent, doesn't actually matter what it contains, but it will go be encapsulated into an IP datagram for which the TTL, the time to live field in the IP header, is set to 1. So this will be sent over the link from A to the first router. And as you recall, the router is required to decrement the TTL and then discard the packet if the TTL reaches 0. So it will set TTL equals 0, discard the packet. One more thing that the router is required to do is to send back an icmp message, so an error reporting message, back to A, and it sends it back with a message of I think it's type 11 icmp. Okay, so it's going to send back a type 11 message, which is the TTL expired. That's the icmp message, TTL expired. This is going to tell A, and in order for that packet to reach A, it's going to take, just as before, it's going to take the IP header that was the one that was sent. And it's going to take the first 8 bytes of the IP payload, and it's going to populate that into a message along with this icmp. So let's draw this like this. So this is going to be the icmp message coming in here. This is going to be that digest of the original IP message. It's going to put this into an IP datagram, and it's going to send it back to A. So when this reaches A, it's going to know from this message there was a TTL expired, and from this portion, from the data, the payload portion of the icmp message, it's going to know, aha, this came from a message I originally sent from A. It's going to come from the router, so the IP source address of this datagram is going to be the router, so I'll put that in as R. So that knows that it was this router. It can look up its name, and now it knows that the first hop router is R, and by measuring the time that it took from when it sent the original IP message until it received this icmp reply, it now knows the round trip time to that router. The next step is probably pretty obvious. Next, A is going to send a UDP message, put into an IP datagram, and that is going to have a TTL of 2. Okay, so this is the IP datagram that goes out. So it'll go through to the first router, that'll decrement the TTL to 1, come through to the second one, it'll decrement it to 0, and then this one will send back an icmp message, so the datagram will look like this. I'll now draw the IP datagram with the icmp message inside. So this is the IP datagram. This is going to be going to A from, let's call that R2. And inside is going to be the icmp message. So this is the icmp message that it's carrying. It's going to say type 11, which was the TTL expired. And then it's going to have the original IP header plus 8 bytes, so that when it gets back to A, it knows what message this was referring to. It can measure the round trip time. Now it knows, based on the message coming from R2, it knows what this router is, so it can look up its name, and now it knows the round trip time to that router. And it'll do this until eventually the message finds its way to B. The UDP message that it sends is using a port number, which is a weird destination port number. It deliberately picks one that B is not going to know, so that B will send back a message that says, and it's going to be an icmp message, which is port unreachable. And so when it sends back the port unreachable, A knows that the message got, the traceroute made it all the way to B, and knows that the traceroute is complete. So in summary, icmp, the Internet Control Message Protocol, provides information about the network layer to end hosts and routers. It sits above the IP layer, and therefore, strictly speaking, it's a transport layer mechanism, although it's really there to serve the network layer. The commonly used tools ping and traceroute both rely on icmp, and I'd encourage you to try both of them out and play with them. They give you a huge amount of information about reachability and paths through the internet. That's the end of this video.